Here we're going to talk about how to create a set of dummy codes for a multi-categorical variable and then how to use that in a regression. And in this video we're just going to do a straightforward regression where the only variable in the model, the only regressor, is represented by the set of dummy codes, so there isn't any second variable or third variable. So this is a fake data set from the textbook, and we have 4 variables. We have marital status, single, divorced, widowed, married. We have life satisfaction, we have income, and we have sex. And we're not going to really worry too much about income and sex. We're just going to see if we can predict the life satisfaction of somebody based on their marital status. And so what you can't do is just include marital status as a regressor in a regression and trust the results that come out. It just won't work. What we need to do is we need to create a set of dummy variables, each of which represents those who belong to a certain status, so single, divorced, widowed, married, with the wrinkle that we only include all but one of the categories. So however many categories you have, we're going to create one less dummy variable. So since there's 4 marital statuses, we're going to create 3 dummy variables. And so the first thing that we need to do is to choose which is going to be our reference category. And our reference category is going to be the baseline that we compare the other groups against. And it doesn't really matter which one you choose in terms of looking at the overall results and whether the R-square is bigger or smaller, and if it's significant or not. But the comparisons that we get will be a little bit different. There's one sort of set of things that will show up, and other things will not show up, depending on your choice. So if there's a good sort of comparison group that it makes sense, either based on your hypotheses or just based on logic, to be kind of the baseline or reference category, then we're going to include that. We don't actually have to make that choice right now, though, because the way that we're going to do this in R is to use a function called dummy calls, and dummy calls comes from the fast dummies package. And so I've already loaded fast dummies up, but if I hadn't, you need to make sure you have it installed, and then of course you could either just click the box in the packages list, and we can see if we scroll down, there it is. And by default, when we use this dummy calls function, it's going to create a dummy column, a dummy variable for each of the categories, and it's not going to choose a reference category. That's not a problem, though, as we'll see in a second. So here's how we go about doing that. So what I'm going to do is I'm going to create a new data frame based on this data frame. I'm just going to call it LifeSat2. And this is going to be based on the dummy calls function, and we're going to include the original data frame name, LifeSat, and then we're going to use this select columns function. And we're going to tell R that this is the column that we want to create dummy variables from. So I put that in double quotes, M status. Okay. Now if we didn't include this and we just put in LifeSat, what it would do is it would look through the variables and it would create dummy variables for any factor that was in here, anything that had categories. And actually both M status and sex have categories. So it would create a series of dummy variables for M status and 2 dummy variables for sex. But we don't need one for sex, even if we're going to use this in our regression, because it's already dummy coded 0 and 1, and we only need one of these. We don't need to have, one column for males and one column if people were females. So we don't need this function to do anything here. We're just doing it on M status, which has 4 categories. So we can hit go and take a look at what it did. And we can see we have the original 4 variables in LifeStat2, and then we've tacked on here, we've got 4 new ones, and here we have the 4 categories. So here's the dummy variable for the married status. So you can see anytime we see married here, that turns into a 1, anybody else is a 0. Here's the divorced, so anybody who's divorced, we have a 1, everybody else is a 0. Same thing with single, same thing with widowed. Now there are ways that you can tell this function to skip one of the dummy variables. This one will skip the very first category it runs across. This one will skip the variable, the category that occurs most frequently. But I think sometimes what you want as your reference category is neither of those things. What I think is easiest is just to let it go ahead and create all the dummy variables and then just leave one out. So you definitely don't want to include all 4 of these in your regression, but you can just use this function to create all the dummy variables that there could be, and then when you build your regression model, you just leave the one out that's your reference category. So for me, when I think about marital status, I think single is a good baseline reference category. So I'm going to not include single, and therefore the results we get will be the other 3 compared to single. So I'm going to go ahead and build the regression model. There is one thing that is probably going to be useful if you have a real data set that has missing data in your categorical variable. You don't really need or want a reference category created for the missing data as if it were a separate category. So if this was a large real data set with some missing data, then I would include this ignore NA equals, and then I would put true. It's false by default, but I would add that in here at the end after a comma. Okay, so let's go ahead and run the regression here. I'm going to call it mod1, as I tend to do. And we're going to try to predict satisfaction as a function, not of marital status as it originally was in the data set, but as a series of dummy variables. We're going to leave single out, like we said, because that's our reference category. M status married plus M status divorced plus M status widowed. And then we have to tell it that the data set that we're using is LifeStat2. Okay. So this is one variable, marital status, but it's captured or represented by 3 dummy variables. So let's take a look at our results. I've already loaded up the car package, so I can use this S function. We'll just take a couple minutes to look at what we've got here. So we're predicting life satisfaction based on somebody's marital status. And we've got an R-square of 0.42, so we're explaining 42% of the variability in satisfaction based on what somebody's marital status is. I'm guessing this is much higher in this data set than it would be in real life, and that this is significant at 0.029. Now, we go into this in class, but the intercept for this regression, and this is only true when we don't have any other variables in the model. Otherwise, it's a little bit more complicated. But when all we have is a single categorical variable, the intercept is the mean of the reference category. Basically, if you are 0 on married and divorced and widowed, that means you're single. And so the intercept, which generally speaking is what our y-score is when x is 0, or all the x's are 0, that still applies. But all the x's being 0 in this case means that you're a 1 on the reference category. So this 82.4, that's the average of single people, the reference category. And then each of these predictors or regressors is telling us the difference between that group and the reference category. So married individuals on average are 3.1 points higher than single people on life satisfaction. Divorced people are 3.2 points lower than single people, and widowed people are 10.9 points lower than single people. Again, this is fake data, don't read too much into it, but this is how we would interpret these coefficients. This is the mean difference between this category and the reference category. And then when we look at the significance, we can see that the only significant difference comparing the single people to any other group is the widowed people. So there's a significant difference between single people and widowed people, with widowed people having lower life satisfaction. But married and divorced people are not significantly different from single people. So that's how you would go about interpreting those. And one last thing is that, as we talk about in class, if you look at this and you think what we've got here is kind of like an independent variable with 4 levels, and then a dependent variable that's continuous, this is giving us essentially the same exact results we would get from a one-way ANOVA, where our IV is marital status and our DV is life satisfaction.